Welcome back, students. So now I will tell you how these electrons, protons and neutrons, they are arranged in an atom as proposed by various models. J.J. Thomson coming into picture, you will see Rutherford coming into picture, Niels Bohr will come into the picture. So let's begin with the slides which I made exclusively for you guys.
Let's now discuss various atomic models. So the first model of atom was given by J.J. Thomson. Thomson's model, it is very famous, known as plum pudding model, as a plums on pudding on cake. And he proposed the model in 1904. In 1904 he proposed the model, and what did he represented the model as? That atom was a sphere of positive electricity, okay, or ions, I would say, ions, in which the embedded were electrons, okay, sufficient to neutralize the positive charge. Means it was a spherical kind of thing like this. This is a positive sphere and electrons are embedded. That's why it's also known as plum pudding model, given by J.J. Thomson. But the stability, how he was trying to explain, he said that it is as a result of balance between the repulsive forces of electrons and their attraction towards the center of the positive sphere. But this model couldn't satisfactorily explain the results of scattering experiment which Rutherford conducted. So now let's see what is Rutherford model of atom. He is very famous for this experiment known as gold foil experiment, in which he used alpha particles which are emitted by radioactive substance. What is alpha particle? It is a He2 plus ion. So what he actually do, he allowed the narrow beam of alpha particles to fall on a very thin gold foil. He used gold foil AU of thickness of order 4 into 10 to the minus 4 centimeter, and determine the what paths they are taking, and with the help of again zinc sulfide fluorescent screen. So the zinc sulfide screen, it gives a visible flash of light whenever alpha rays hit at that particle. So in that way, the kinetic energy of the particle gets converted into the visible light. And this is a note here that Rutherford specifically used alpha particles because they are really heavy, resulting in high momentum. And whenever those high particles would hit that zinc sulfide layer, then it will have a scintillation pattern observed. This was the model. So here is the source, okay, of alpha particle. This is the radioactive source, and it is emitting what? Alpha particles. And these alpha particles, when hit the AU, the gold foil here, so what he was observing, that most of the alpha particles, they travel through the foil undeflected, most of them. So that means the atom is almost empty, which earlier what J.J. Thomson was saying, that it's like a positive sphere. So it is not like that. Then some of them were deflected by the angles. So what he can interpret? He can interpret that nucleus is positively charged, as it is alpha particle. Okay, and there was some alpha rays which travels directly back 180 degrees. So that means the positive center of the core of atom is concentrated in a small center, and that is the nucleus. So these are again the observations which I have already told you. The majority particles, they pass straight, okay, and some of them were deflected with their path, some got deflected by 90 degrees, and there were a few, means 1 in every 20,000. It seems like they deflected by 180 degrees. Okay, 1 in 20,000. And this is the distance of nucleus where alpha particles they returns back to 180 degrees. This is known as what? Distance of closest approach, means how close they may appear. They may come towards each other. And so on this basis, what Rutherford proposed, he said that all the protons and neutrons, which is nearly the total mass of any atom, it is present in very small region, which I was saying center core. Okay, so that is nucleus. Nucleus was a term coined here. And what is the size? The size is the diameter of nucleus is about 10 raised to the power minus 13 centimeter, while atom has 10 raised to the power minus 8. So it's a order difference of 10 raised to the power 5. And most of the space outside the nucleus is empty. And electrons, which are equal in number to the protons, they revolve around the nucleus with fast speed in some, say, circular orbits. But again, even this model was having some defect. What was it? The first is the position of electrons. That exact position of electrons, where they are revolving, where is the circular path. And the second is the stability reasons. That Niels Bohr, he said that Rutherford atom should be highly unstable. Why? Because electrodynamics was very favorite subject those days of the scientists. And according to it, the electron should continuously emit radiation, and if it is happening, then what will happen? Suppose I'm drawing it here. This is the path of circular path, say, of the electron, which is revolving around the nucleus. This is my nucleus. So if it is emitting radiation, means it is emitting it is losing its energy also, right? So what will happen? One time will come when this will hit the nucleus, and this system will become unstable. But it doesn't happen. So this is the reason that there is some defect in the Rutherford model of atom as well. And it has been calculated that it takes even 10 to the power minus 8 seconds if it, the electrons move like this way and hit this nucleus. So next comes Bohr's model of atom, which is, very, very evolved new model given by Niels Bohr. Okay, and it is very well valid for one electron system, okay, or hydrogen species. So what he said, that electrons, they are moving in some confined path, which we'll just learn that what is that confined path actually. You can see the confined path, and in the center you have nucleus. Okay, so all forces are coming now into the picture: the centripetal, the electrostat, that we'll see. So he said that we have nucleus in the center and electrons are moving some very, very circular path, and which is well defined. And the force of attraction, okay, so here comes the force now. The force of attraction between the nucleus and electron, that is equal to the centrifugal force of the moving electron. And what was those paths consisting of? Electron can revolve only in those paths whose angular momentum, MVR, it is an integral multiple of h by 2 pi. That means MVR is equal to nh by 2 pi, where m is your mass, v is your velocity, r is your radius, okay, n is the orbit number. Sorry, m is the orbit number. And why this model was very, very well accepted? Because of many calculations, okay, which come true when they were observed by a meter called spectrometer. I hope you all know about mass spectrometry. Okay, mass spectrometry techniques to find the mass. So electrostatic force, which is kZe square by r square, that is equal to my centrifugal force, so mv square by r. From here you can find v in terms of radius, mass and the electronic charge. So, and also according to the Bohr's postulate, mvr is equal to nh by 2 pi. So combining these all, you can get the radius. That radius is equal to n square h square by 4 pi square mkZe square. And when he used the standard values of these electron, atomic number, mass, then he found it out that experimentally also it is coming true. Okay, so that's why this model is very well accepted. And here you have the radius of nth orbit in the form of z, like this way. Rn, that is equal to 52.9 picometer, that is 0.5 to 9 angstrom, n square by z. You can directly use this formula. Now, how to calculate the energy? Again, the same procedure. What is kinetic energy? It is half mv square. Velocity you have already calculated, so you can directly put the value. Potential energy is this much, and total energy will be this much. So, by putting the value, you can see that the total energy is minus kZe square by 2r. And if you substitute the value of r, you will get my E, that is equal to 2 pi square mZ E dash k square by n square h square. For velocity also, we have the derivation as, suppose, mvr, which is equal to nh by 2 pi according to the postulates of Bohr. V will be equal to nh by 2 pi mr. Just substitute the value of r and you will get the value of velocity. So v, that is equal to 2.18 into 10 to the power 8 z by n centimeter per second. Remember, the unit is centimeter per second. So this is using CGS system here. Now come to merits of Bohr's model. So first of all, that they all are in the good agreement with the experiment they conducted, okay, the values. Also, the Bohr's concept of stationary state of electron explains all the emission and absorption spectra. So this emission and absorption spectra, this we will understand in detail in the next parts. But what is actually, I must tell you, that they were like, the fingerprints of any human being, if you observe, so they will be unique. Even the DNA testing, that is unique. So in the same way, these spectral lines of any atoms, they are unique. So Bohr's model was able to explain those spectral lines, and that's why the model was very, very well accepted. Then, whatever is the experimental value in the spectral lines, they are in close agreement. That's what I said. But there is limitation as well. Why? Because it doesn't explain the spectra of atoms more than 1 electron. Means this system is valid only for hydrogen or hydrogen-like only. So this was the limitation. Also, Zeeman effect and Stark effect was not able to get explained by this model. So de Broglie suggested that electrons, they have dual character now. So it has a particle and wave character. So now Bohr was trying to treat only electron as particle. Now in the further slides we will see that how well the duality nature is evolved and used in understanding of atomic structure. Also, another objection was from the Heisenberg uncertainty principle, okay, which says that electrons evolve in definite path. But according to that, Heisenberg uncertainty principle. If you are measuring, x, then you cannot measure v very perfectly. So it was the flaw again.
Well, students, so in this part, we saw various models proposed by, say, J.J. Thomson proposed the plum pudding model, then alpha ray scattering particle was done by Rutherford, and with all those drawbacks, Niels Bohr coming into the picture and proposed his model of orbitals, that electrons are moving in orbitals. Now, with that basic knowledge, guys, there is something which is unique to every atom, like DNA fingerprinting, which is unique to every human. That is known as electromagnetic spectrum of elements. So in my next part, I'm going to tell you about what electromagnetic spectrum is. What is, first of all, electromagnetic radiation? So stay tuned with me for that.